Hello, good evening. In tonight's Omar Vision tutorial, we're going to learn about using Perlin Noise to make hills. All right, so what we're going to do at the end of this tutorial is be able to do something like this. Boom, some nice hills in 3D generated by the script. Okay, so to do this, we're going to use something called Perlin Noise. Now I have a couple of game objects here. This last one that I just showed you is our end result to generate some cubes in two directions, the X and the Z. But to understand what the Perlin value does, let us first take a look at this first game object here that I have called Perlin value. All right, what it has is in the inspector, it displays that I can give a value for the X and the Y to feed into the Perlin Noise algorithm. And then the output of the Perlin Noise algorithm will show here. The script for this is pretty simple. I have the two public variables, Perlin position and Perlin noise. And in the update function, which runs every frame that the game plays, it will calculate the Perlin noise of whatever Perlin pos X and Perlin pos Y are. All right, so let's press play. So I press play. There's nothing to see here. It's all about looking here in the inspector window right now. So at position 0, 0, I have a Perlin noise value of 0.465. At position 5, 0, I have a Perlin value of 0.465. At position blah, 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 big giant number, a 0, I have a Perlin noise value of 0.465. Well, that's really not working, is it? Is it? It is working. What the Perlin noise function takes are decimal values. If you give it a whole number value, it's going to give you its whole number value position, which is that 0.465 right now. So if I use decimal values for X instead, you could see that the Perlin noise value changes. Okay. I could do the same thing and give a value for Y. The value changes. Now, if I gave the value of 0.5 for X and 0.5 for Y, the value is for the Perlin is 0.296, blah, blah, blah. Okay. Now, if I get the value of 0.51, it's 0.2907. 0.52, 0.2845. It doesn't change too much if these numbers don't change too much. And if I go back to 0.5 again, 0.5, enter, it's 0.296. Always the same values. So whatever values I put in here, if it's the same values I put in here, I will get back the same value output for the Perlin noise. Okay, so let's just think about the rules of that. I wrote them down here in the script. The closer the Perlin position values are, the closer the Perlin noise values will be. Then any two Perlin pos values will always return the same Perlin noise value, just like when I did 0, 0. Let's do that again, and it gives me back 0.465. And if I do 0.5 and 0.5, it gives me back 296. It'll always be the same value. And third, don't pass in whole numbers because whole numbers will always give you back the same value. You must pass in decimal numbers to get different results. All right, let's think about those rules and let's go on to our next example here. So I'll turn off the Perlin value game object and turn on my bouncing cube object. Let's see how the Perlin values look in motion as they're moving. All right, so what we're going to do here in this script is we're going to just move forward in time and feed that time value into the Perlin noise, into one of the positions for Perlin noise. And we're going to put the position of the cube to whatever that value is. So we could see how the value changes with Perlin noise. And we could see that it changes smoothly. So my bouncing cube, let's go to the Perlin bouncing cube script. Yes, here's those 3 public variables you see in the inspector. And the elapsed time is just going to equal time.time. This is the update function. And then we feed the x value here, and the y value, we'll leave it the same. And that'll give us different Perlin noise values from 0 to 1. And then I'll position the cube that this script is attached to. I'll position the cube, x and z, they'll stay the same, and I'll just keep changing the y by this value between 0 and 1 times a multiplier, so we could actually see it move up and down, because 0 to 1 doesn't really move that much. All right, that's the script. Make sure you save it, and I'll go back here and we'll press play. Do I have to change anything here? Only thing I have to make sure is I have a multiplier. All right, let's press play, and time is moving forward. And as time moves forward, we can see the cube is going up and down smoothly, bouncing, scrolling up and down, because the values that are returned for the elapsed time change slowly up and down. Okay? And it's random. It's not a consistent bounce. Good, 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 good. Now if I change the multiplier to a bigger number, like 20, let's see how much it bounces. It's going to show the bounce more exaggerated because the multiplier is more exaggerated. But the bounce is always the same. It's always up and down the same thing at the same values for time. Okay, so now you can see how Perlin looks when it's in motion, when we're feeding values as they go up, that it kind of repeats. Now let's do a 1D generation and use those up and down values, but plot them across the x-axis to make hills, okay, in 1 dimension. So let's turn off the bouncing cube game object, and let's turn on this one, CubeGen 1D, which has a script attached to it. Let's see. Okay, this script has shows our Perlin noise value, shows our refinement and our multiplier, and cubes. The new value here is refinement. So we're going to use a loop to loop through how many cubes we want to plot on the x-axis. So cubes here, what did I say? It's 50. Okay, so we're going to have 50 cubes across. And how high they're going to be plotted is depending on the Perlin noise value. So let's see. So we'll have a loop for the cubes from 0 to 50 is what our value is up there in the inspector. And we're only going to do a 1-dimensional movement. So for the second dimension, we'll just put in 0 all the time. And for this first dimension, we'll put in I as it's moving along, times refinement. All right, so we're doing times refinement because I is an integer. It's a whole number, and remember the Perlin noise needs decimal values. So refinement is that. Refinement is how we're going to change the integer from 0 to 50 to a decimal value. We'll just multiply that integer times a decimal value, which turns the integer into a decimal. Okay, and then we'll create a cube here in the script. We'll create a cube game object, and we will set the position of that cube game object along the y-axis as we're moving along x, and the height of it will be the Perlin noise value times the multiplier, and on the z we'll just leave it as 0, so it's a one-dimensional hill. So let's go look back here and run this and see what comes out. Let's see, the refinement is 0.01 to make sure we have decimals, and da-da-da-da-da-da. Okay, press play, and what comes out? Ooh, it's a snake. All right, we got a snake here, and it is in the 1 dimension. The red line is the x dimension here going across, and we can see all the different values plotted out, and we could see how they are, smoothly changing up and down. All right, Now, I was thinking of a Minecraft game where everything's in voxel space. I was working on a Minecraft game, so that's why I have this little quantize thing here. So as these values are going smoothly up and down, if this was voxel space, all these little in-between spaces of voxels, they'd have to lock into, positions of whole number voxel spaces instead of being between two voxels. So that's what my quantize does. If I click the quantize over here and run it, it will, instead of running this if statement, it'll go to this part on the else. And what it does is it takes that Perlin noise value, which is a decimal value for the y, and it rounds it off to an integer. So it kind of quantizes it into a voxel position if I was doing a game like Minecraft or something, okay? So now I have the quantize checkbox, and let's see what happens from that smooth little snake. What does it look like when it has to lock into positions of 1? It's a little more rough, okay? But you could see if this was a big old voxel world, that's how I translate it to be something voxel-wise. And this is a 1D Perlin representation. But you see, every time I ran this, the randomness kind of generated the same way. And the amount of hills I have will depend on, what will it depend on? Let's see, I took the refinement to 0.1. How about if I made it 0.15, just increasing it a little? Does that give me more hills or less? That gives me more hills. See, but the first hills, they're kind of the same. They just kind of got squished up together more, and it added in another hill over there. So that means if I do 0.15, how about if I do 0.18? Let's see what happens is I get the refinement number bigger. Do I get more hills in? And yep, I got another hill in there. As the refinement gets bigger, I get like more hills concentrated in there. That means if the decimal value is getting bigger, that means if it gets smaller, I'll have less hills. So let's turn the refinement down from 0.1. Smaller would be 0.08. So I should get less hills. Yeah, okay, let's try 0.06. Less hills than that. Yep. And if I just tried 0.04, as the numbers get smaller, I get less hills. As the numbers get bigger, I get more hills. And you see I have less hills. All right, and then of course the multiplier is how high the hills are. If I went to 20, you would see that it just has more exaggeration of the hills, okay? So that was my one-dimensional example. So what would happen if I did this using Perlin noise on the X, but I also used it on the Z axis? What could I get? Since Perlin noise takes two values from Unity. So here I have my CubeGen 2D where I feed in two values to the Perlin noise, not just one. So the script for that is right here. So instead of just feeding in the one loop of the I values over here, I have another loop in, two nested loops, and the inner loop is going to feed in the second value. Okay, so now with two values, I'm kind of looking for values that go along on the x-axis, and then for every x, I'm also going to go back and do it on the next, on the next z, and now I'll get like hills in 3-dimension. All right, so that's the difference here with this one is I have two loops instead of one loop feeding in one value. I'm going to have two loops feeding in two values, and then when I position my cubes that I'm going to generate in script, I'll have the x-axis and the z-axis value. Okay, so let's see what this looks like if I press play, which I'm going to do right now. And voila, I have something in 2 dimensions. But as you can see, it is a bunch of one-dimensional Perlin cube generations that are changing in this direction in the X. But if I look down the Z, it's also doing the same thing in the Z. It's making the hills. So it's funny, the Perlin noise makes values that are close together in both dimensions, in the X and the Z, so that if I plot it out, I have smooth little hills with the Perlin noise function. And I could do the same thing that I did with the 1D. I could, if I want more hills, what do? I have to increase the refinement number from 0.1 to maybe 0.14. That's a bigger number. And let's see how that looks. I get more hills in the same amount of space, and it looks a little bit more bumpy. And let's try, like, I think the highest one I did was 0.18. And let's get even more hills in there. It's even bumpier, okay? Or I could have some smooth dunes. I go back to 0.1, and let's just see what happens if I add more cubes. Like instead of 50, I add 100 in each direction. Oops, I forgot. I was in play. I had to stop the game first so it remembers the values. Let's see, and I say 100 cubes instead of 50, and it's the same thing. It's just bigger, okay, and wavier. So I could do. So this was this is the end of the tutorial. What do you think? Like and subscribe. Tell me how great I am so I can feel better and make another tutorial. And see you guys later. Bye.